So like you ask like, suppose you purchase some IP address from the ISP. Okay, you purchase some IP address from the ISP. It means IP know about that IP address. If I am getting QoS from that IP address, so in which direction, on which router we have to send our reply packet. You can see here I have some public IP address 158, like 178, 158, 51, 120, 118. Like this, I have some public IP address. I purchase this IP address from the ISP. Because ISP know if I am receiving any request packet from this IP address, so on which direction and what is my next hop. So he know. So suppose this is your diagram. Inside today is working fine now. Enjoy the day. Okay, so this is your ISP. I'll close this. If you're feeling good, then you can decrease. I see. Switch. Okay. And this is your end device, edge device, not end, edge device. And this edge device is connected with the ISP, like this. Okay. So I purchased some IP address from the ISP. Like I purchased three IP address 192.168.100.0.0.1, 100.0.0.2, and the 3. I purchased some 3 IP address. So one of the IP address I'm going to assign here on this port. I can assign any IP address, .2, .3, doesn't matter, because we purchased 3 IP addresses. And when I'm receiving it, like ISP is receiving any request packet from this IP address, so he know like if I'm receiving the IP, like request from the .1, so I have to forward my data on this one. If I'm receiving any request packet from the .2, so we again, this is the direction. Directly connected routers. If suppose I have a 2 ISP, okay, and one of the IP ISP gave me this 100 network, and one of the IP ISP gave me 200.0.0.1, 200.0.0.2. Okay. Already on this interface, I configured this IP address. Okay. Now I'm translating my private IP address with this public IP address. Means when I'm sending my request packet, so my source IP address is 200.0.0.1. So in this scenario, ISP doesn't know like where is this IP address. I'm sending my request from the ISP1, and the ISP1 gave me this IP address. Okay, but ISP do know like this IP address I gave to this R1. So here I have one more ISP. So they are exchanging their information. On this WAN side, also we have one routing protocol, maybe OSPF or maybe BGP. So they are exchanging their route. So from the ISP2 is sending the information to the ISP1. If he wants to reach 200 networks, so just send this R1. To send that packet to the R1. Means we have a route here. So now our static. No, I didn't assign anywhere. It is just in my router. ISPs have information like if I want to reach to that particular destination, I have where I have to forward my packet. Because it's a public IP address, they know where I have to reach. It's not a private. It's a public IP address we purchase from the ISP. So it doesn't matter like we are purchasing IP address from the ISP1, ISP2, or ISP3. They are this WAN technology like WAN area. It means they are using some routing protocols, maybe OSPF or the BGP, and they are exchanging their information. And also this interface is a part of the WAN area. So ISP know like on if I want to reach 100 networks, so where I have to send my packet, and ISP know if I am receiving the packet from the 200 networks, so where I have to send my packet. They know because this is your WAN technology, like WAN area. So today's task is dynamic net. What the meaning of static net? One-to-one mapping. Like we have one pool of this our private IP addresses, and this is a public IP address pool. Private IP address and the public IP address. And 2.168.1.0, 192.168.2.0, 2.0, 1.1, 1.2, 192.168.1.3. So like this, we have some IP addresses. And here in the public IP address, like public IP address pool, we have some IP address 100.0.0.1 and 100.0.0.2. That's it. We have only two IP addresses. So in the static, we are making the one-to-one mapping. Like this is my public IP, like private IP address, and this is my public IP address. I want to bind this public IP address with this private IP address. It means that public IP address is going to permanently fix with that private IP address. It doesn't matter that private user is using the internet just for the 5 minutes or 10 minutes. It doesn't matter that public IP address is going to reserve for that private one. Same like this 1.2 is going to bind with 100.0.0.2. Yeah. Now we had only two IP address, and they're going to bind with this IP address 1 and 2. Now what about this third 1.3? We don't have any public IP address, so we can't bind with that private user, so it's not able to take the internet access. And the static, there is only one disadvantage is like this IP address is going to bind with the particular user permanently until and unless we are not removing that condition. Doesn't matter this user is going to use internet just for 5 minutes or the 10 minutes. The public IP address is going to use. So after 5 minutes, we purchase this IP address for the 5,000 rupees. The cost of the one public IP address around 5,000 per month. Okay. So this user is using the 5-minute internet per day. So it's very costly. It's useless. So with the help of the dynamic, when any user send the request like I need an internet connection, then your router is going to check, like first we have to create one public IP address pool. Any user sending the request to the router, I need an internet connection. So your router is going to check in your public IP address pool if we have any free IP address or not. So as of now, we have two free IP address. So the particular one, first IP address is going to assign with. Suppose 1.3 is sending the request, like I need an internet connection. Your request reached to the router. Router is going to check, do we have any free IP address or not? If we have, then allocate to this user. Now my both IP address is assigned to different user. Now 1.4 again is sending the request to the router. I need an internet connection. So it's going to check, do we have any free IP address or not? So this scenario, we don't have. So this packet, after some time, this packet will going to drop. But after some time, your router one is going to release that IP address. It's going to release that IP address. First it take the access, second one also, but after some time, your first user is released that IP address, like it's telling I'm done with my work. You can take your public IP address. Now we have one more IP address, free IP address. So when 1.3 is sending the request to the router, like I need an internet connection, it's going to check, do we have any free IP address? So yes, we have free IP address. So that IP address is going to assign to that user. Clear? This is your dynamic net. But again, in this, we have one more disadvantage, like at the time, only two users can access the internet access. Why? Because we have only two public IP addresses. Here we have 4 users, but only 2 users can access the internet. Why? Because we have only two public IP addresses. Okay. So for this task, what we have to do? We have to create our pool. Before it, we have to define our inside and outside. Inside the pool, which interface belongs to inside and which interface belongs to outside. So we have to declare our inside outside. Then we have to create a pool, public IP address pool. Then we have to create our access list. Why? Because I want to define like for which network I want to apply, like in your network, we have 10 network, 20 network, 30 network, 192, 172. We have multiple networks. So I have to tell my router, whenever you are receiving requests from that particular network or for particular range of the network, then you have to translate the private IP address into the public IP address. So this condition we can apply with this access list. Then our network. Okay. So we have logs, you can check it. Okay. So start your Cisco packet tracing. So again, same topology I'm taking. I need two routers. This is your ISP. This is your router 1. I need one switch. And again, 3 PC. 1, 2, and 3. Same yesterday topology. It's not going to be different. This is yours. Inside one, and this one is your outside. And this is your ISP. Yeah, because you are purchasing the IP address from the ISP. So ISP knows if I'm receiving the packet from 100 networks, so yes, definitely we know like where I have to send the packet. Yeah. We have to define that route. Like you can say we have 3 IP addresses, 1, 2, and 3. So first IP address is going to assign on this interface, and we have to create our pool with these 2 IP addresses. So quickly, I'm going to configure my routers. First ISP. Zero, then IP address 100.0.0.10.5.5.5.0. This is your ISP. R1, 1015. S F0 by 0. There's my inside 192.168.1.10, 255.255.255.0. Now, on the exit side, F0 by 1, we have to assign our public IP address. And here we have 3 public IP address. We can assign any one, 1.1.2.3, depend on you. So 100.0.0.1, 255.255.255.0. Like you can see here, I have 3 public IP address. I can give any IP address on my exit interface. ISP. Why? Because you can see here, when we are purchasing any IP address from your ISP, so you will get the IP addresses. Also, you will get the default gateway. So in the router, we have to define one default route. If I am receiving any packet from the any IP address, just we have to forward to this gateway. With the help of this, we can get the internet connection. Doesn't matter, like you are using 158, 51, like you have some different IP addresses also. So you can use default gateway and you can send your packet from your inside to the outside. Yeah, because this default gateway, it means like ISP IP address. Means with this IP address, I can reach to my ISP. This information you will get when you are purchasing any new IP addresses. Default gateway, it means your ISP router. Yeah. Okay. And also change the host name ISP. This is your router. Now configure your PC. One 192.168.1.1, 192.168.1.10. We need our default gateway because we need internet connectivity. So 192.168.1.2, 192.168.1.10. Yeah. 192.168.1.3, 192.168.1.10. Now, do we have reachability from PC1 to the ISP? Means laptop 1 to the ISP? Yes. Who said no? Online guys, do we have reachability from the laptop 1 to the ISP?
One side reachability.
Request packet will reach to the ISP, but reply packet won't. Because we don't have any route in this ISP regarding this 192 network. Actually, no, we don't have any reachability because this is your 192.168.1.0/24 network, and this is your 100 network. Your request packet will reach there to the ISP, but we are not going to get reply packet. You can verify like this. Just fire debug command here. Debug IP ICMP. Come to the laptop 1 and send the IP. Try to ping 100.0.0.10. Okay, request timeout, request timeout. We don't have an internet connection. Come to the ISP. You can see we are receiving request packet, but while sending the reply packet, what's your destination IP address? 192.168.1.1. In the ISP, how many IP addresses we have? One IP address, 100 network. It means we have only one network information. Check the IP route. So IP route, we have only one network information. But when you are sending the reply packet, so your destination IP address is 192.168.1.1. Your ISP doesn't know about the private IP address. That's why your reply packet is going to drop here. So what we can do? We can translate our IP address because we have a public IP addresses. So at this time we have to do dynamic net. So first we have to define which interface belongs to which zone, inside or outside. So F0/0 is inside and F0/1 is outside. Inside interface F0/1, IP net outside. Then what is our third task? Like next, we have to create our pool, public IP address pool. IP net, new question mark. You can see the third option, pool. What's the pool name? Test. And static IP address. Like in this dynamic net, we have one disadvantages. You can see here in the publicly, we are receiving the IP address randomly, 178, 18, 171. Randomly, it's not a sequence number. It's randomly they are giving. But in the dynamic net, it's asking me as a like a starting IP address, start IP address, 100.0.0.2, because one is already defined on the interface. Space, question mark, and IP address. It means here I have to assign the pool like sequence number, like 1, 2, 3, 4, 5, 6, like that. I can't define here like particular. I have an IP address .10, I have one IP address .15. So this is the disadvantages of this dynamic net. So we are not using this dynamic net in the real time, just for the course purpose. Okay. Now we have to define our net mask. Net mask in the sense your subnet mask. So 255.255.255.0. This is my subnet mask. Space, give question, nothing. So this is your syntax for the pool. IP net pool, pool name, your starting IP address, your ending IP address, then subnet mask. Net mask with subnet. This is your syntax. Now, what's your next step? ACL, access list. And the access list, we have defined which network I want to translate with this public IP addresses. And here you can assign, like you can create standard, doesn't matter. Just we have to define our network, source network. So access list 10. With the help of the permit statement, you can define. Then your network 192.168.1.0 space question mark wildcards 0.0.0.255. Okay. I define my network. This network I want to translate with my public IP addresses. Okay. Then what is the next task? Access is done. Now net rule. We have to define our translation rule. You have a pool, like in your organization, you have a different networks, 10 network, 20 network, 30 network, 192 network. But your task is like if I am defining translation without access list. So if 10 network users sending the request to the router, so we'll get the translated and we'll get the internet access. But my task is I want to allow the internet connection only the 192 network. How can we achieve? So we have to define which network I want to translate. Now, our IP net source. I want to translate my inside zones IP address. Source. Now, static or list? Definitely list. Static means one-to-one mapping. We are doing dynamic task. List. So here we have to define our access list number. You can see here access list number for the local IP addresses. This list, it means like which interface inside IP address you want to translate with your public IP address. So list, we created one access list. And then you question mark. You want to translate your inside IP addresses with the help of interface or the pool. We created one pool. So pool. Then what's your pool name?
Test.
That's it. IP net inside. Source is my list 10. It means in the list 10, I define I have to translate my 192.168.1.0 network with the help of this pool test. That's it. So first we came into the interface inside, then outside, then we created our pool, then we created our access list, and in the last we defined our translation. Okay. Only this task. Now take the translation. So IP net translation. As of now we don't have, because it's not our static one, it's a dynamic one. Now come to your PC and try to ping to the 10.100.0.0.10. Request timeout. First request timeout because first is going to check the what you can say the art. Now you can see the translation. This is your source one, and this is your translated IP address. Now, same time I want storage from the laptop 2. In 100.0.0.10. Do we have reachability? Yes, because we have 2 public IP addresses. Yes. So again, check the R1. So we have 2 translation, 1.1, 1.2, 0.2, and 0.3. Now come to the laptop 3 and check the reachability. Do we have? Ping 100.0.0.1. Why? Because all IP addresses are occupied with the different public IP, private IP addresses. When any of your user is releasing that public IP address, after that we will get the internet connection. You can see here still. Now your first IP address, like first laptop 1 is going to release that IP address, then that's why we got the internet connectivity. You can see here 1.3, it took the .2. Let's do one thing. Come to the ISP. Configure your telnet service. Line VTY. Space for login local. Password CCNA. That's it. Local password. We discussed about this. This is a local password for the telnet. We have 2 options: login local and the local only.
We need to create
login only.
Yeah.
Yeah. No login local. Just login. So it's going to use this password. Okay. Come to the laptop 0. First check the reachability. Do we have or not? So yes, we have reachability. So scroll down. Telnet. 100.0.0.10. So we have reachability. Now come to the laptop 3 and take the telnet access. 100.0.0.10. So we have. What about the laptop 2? We don't have this access. No reachability. No reachability. Why? Because both IP address is already occupied with the different private IP addresses. Okay. So you can check here. Come to router and check your translation table. So IP translation. 1.1 is going to occupy with the .0 and 1.3 is going to occupy with the .0. .3. For the TCP, like it depends on your protocol. ICMP is taking around 5 to 10 seconds, something 5 to 10 seconds. But TCP around 1 hour, maybe I'm not sure, but maybe it's for taking 1 hour, I guess. TCP.
Sir, can we release the forcefully?
Yeah, you can release. You can release.
Okay.
There's one command. Clear IP net translation. Star delete all.
Okay.
Nothing.
Again.
Now come to the laptop 2 and try to take the telnet access. 100.0.0.10. So this time we have. Here, any doubt? Do this task. Take the routers and configure your dynamic net. And this is your command. Only this much. And this commands you have to fire and this R. Okay. Do the stars, then we discuss about the fat. Yeah. Without any query? Huh? Okay. Like with this command, you can clear your translation table. Just we have to file clear IPNet translation, delete all the dynamic translation. With the help of this command, you can clear your translation table. This is my translation table. I want to clear this entry. Yeah, because in the translation table, you don't have any entry. It means all IP address is going to free. If you are receiving any request, so you have to get that first one. No. No class. Yeah, online guys, done? Online guys, done this lab? Rakesh, Venkatesh, Vinod.
Yes, sir. Done.
Okay. Physical guys, wait fast.
Sir, I have a small doubt.
Yeah, whatever.
Just you give an example. ICMP package is it takes 5 seconds, right?
Yeah, 5 seconds something.
So after 5 seconds, automatically the IP will release. Means
Yes,
like it will,
automatic.
can we check that
Yeah.
automatically it is releasing or not?
So do one thing. Uh, Close. Come to the CMD. This is your routing. So IP net translation. As of now, we don't have any entry. Come to the laptop one and try to ping. Okay. Come to the router. Okay.
Right.
Now you can see we had 4. Now it's 3. Now it's gone.
So what is the timer? Means the time.
Normally in the real time it's just a 5 to 10 seconds, but it's a simulator, so maybe it's taking too much time. But real time is only 5 to 10 seconds because just ICMP.
Okay, so if no packet is coming, then it will after 5 seconds it will remove one entries, right?
Okay, done.
Okay, okay.
Now let's move to the PAT translation, port address translation. And this port address translation is not a CCNA syllabus, but we can discuss. Huh? So maybe you just check your pool. In that pool, what's your range? IP address range. PAT port address translation. So just tell me, guys, where we are using the port address translation? Any idea? Guys, where we are using the port address translation? Any idea? Like, huh? So guys, you can see here, this is my public IP address. What is my IP? So here I have only one public IP address. If I'm checking my, if I'm checking in my mobile, so I'll get the same IP address. Same public IP address, because here I have only one public IP address. With the help of the one public IP address, I'm using the internet in the different devices. Okay, different devices. Huh. Like in the net, you can see one IP address is going to assign to the one particular IP address, like one public to one private only. It doesn't matter you are using the static net or the dynamic net. You can, at a time, only 2 users can access the internet. But here you can see I have only one public IP address, and we are using the internet in the different devices with the same IP address. So it's a port address translation. So with the help of the port address translation, multiple users can access the internet at the same time. What the port address translation concept is? It's called a many to one. So here we have a multiple IP address. So like this, we have multiple IP address, and I have only one public IP address, 100.0.0.10. I have only one public IP address. Now I need an internet connection. There is only one public IP address and I need an internet connection. So all your PCs are sending the request to your router. This is your router. In the router, we have all this IP address on the exit interface. Okay? So this user is sending the request to the router. This one is also, they are sending the request to the routers. Now your router is going to translate your all the private IP address to this public IP address. Only one. Only one public IP address. It means when you are sending the request, like here on the Google side, like on the event side, we have one IP address, like on one internet, we have something, or you can say here we have an IP address 100.0.0.100. So when I'm trying to ping from 192.168.1.1 to 100.0.0.100, okay, when this packet is reached to the router, is going to do translation. So after the translation, your packet will look like this. This is your translation. We have to translate our private IP address into the public IP address. So this is your translation. The first packet, it means where you are sending the packet to the router. In the router is going to receive these packets, is going to check the source. 1.1, we have one access list. With the help of the access list and the translation rule, is going to translate your IP address on this format. Source is 100.0.0.10 and destination is 100.0.0.10. Now your packet is going to reach here. This one is going to reach here. So ISP know about this network. If I am receiving the request packet 100.0.0.10, so where I have to send my packet? On this direction. Okay. So when your ISP is sending the packet to your router, so in that we have this information. This is my source IP address, and we are receiving the message on the 100.0.0.10. Okay. This is our packet. This packet we are receiving from the ISP. Now, when this packet will reach here on the router, so the router is going to check, okay, what is our destination IP address? This one. So he's going to check in his translation table. Do we have any entry for this network or not? This IP address or not? So yes, we have. So he's going to do untranslation. With 192.168.1.1. This one. This is your source IP address. This one. It remains same. Just we have to translate this one. So this is your translation and this is your untranslation. In the translation, we have to translate our source IP address. And in the untranslation, we have to translate our destination IP address. Okay, this is your translation. Now, this is your normal translation network. So in this scenario, you can see we have 6 IP addresses and we have only one public IP address. So when I am sending one request 192.168.1.1, it reaches to the router and is going to translate on this 100.0.0.10. Sure? Sure? Because we have only one IP address. The second IP address is going to send the request. Like I need an internet connectivity. So again, it's going to translate on this IP address. Again, 192.168.1.3 sending the request and is going to translate on this IP address. So suppose this is your translation. When this packet is reach here, ISP, after the translation. So after the translation, what's your IP address? It looks like this. 100.0.0.10. The destination is 100.0.0.100. For all these three. 100.0.0.10 and 100.0.0. For the third one also 100.0.0.10 and the 100.0.0. This is your translation. That one. Okay. So when this request, like when this user sending the request to the router, router is going to translate that packet on this format, and this format will reach to the ISP. Same like here for the third one and for the fourth one. Now your ISP is sending the reply packet. In the reply packet, what's your destination?
110, 0.
100.10. This is your destination. When he's sending the request packet, reply packet. Okay, 100.10. So when your router is receiving this packet, like destination is 100.0.0.10, is going to check in his translation table. In the translation table, we have these three entries. So your router, how your router is going to identify this packet is belongs to .1, .2, or .3. So with the help of the port number. So when you are translating your packet, like 192.168.1.1, 192.168.1.2, 192.168.1.3, these are the three users. They are sending the request to the router. So your packet will reach here to the router. 100.0.0.10, 100.0.0.10, here also 100.0.0.10. With the IP address, also you will get the one random port number. So total we have 65,535 total port numbers we have. Total port numbers is 02, 65,535. This much we have. And initially 021024, it's a reserve. It's a reserve. And also we have some different port numbers. It's a reserve port number like 8140, then 8112, 8113. Like this, we have some reserve port number. So you can say total 2,000 ports numbers are reserved from this range. 65,535 is our range of the port number. From this range, assume like 2,000 port numbers are reserved. Okay, and the rest of all are free. So from the unallocated port number, unallocated port number is going to assign some random port number. Random port number like this is going to allocate. So with each and every translation is going to assign some random port number. It can be anything. Random. Okay. So now when you are sending the request, like suppose you are trying to access HTTP or HTTPS or the telnet. So your destination port number is remain same, but your source port number, it can be anything, random number. So when you are sending any request in the translation table, you will get this data also, port number. So when you are sending any request from this PC to the router, from PC to the router is going to assign this public IP address with some random port number. So this request will reach to the ISP. Now ISP is sending the reply packet, and in the reply packet, we have what's our destination IP address, 100.0.0.10, and what's the port number, 2547. This information is there. I'll reply also. Now when this packet is reached to the router, so router is going to check, okay, we have translation with this port number. So it's going to check the IP address plus port number. With the help of this port number information, is going to check what's your private IP address. Okay, this is your port address translation. And in real time, we are using this port address translation.
So when the packet will reach to the 100.0.0.10, so after that, it is going to shift to the 192.168.1.2.
With the help of the port number.
How the packet will look like?
Same like in the packet, we have layer 2 information, layer 3 information, and the layer 4 information. So in the layer 3 information, we have a destination like source port number. First, in the layer 2, what we have? MAC address, AAA. destination triple B, then source IP address 100.0.0.10. This is your source in the request. 100.0.0.100. Then port number, source port number can be anything, and the random port number. This is your packet. The reply packet, your source become a destination, and destination will become a source. Now come to the Cisco packet tracer. First, remove the translation. This one, I want to remove this. No. Okay, there is no translation. Check the access list. So access list, nothing. So IP net translation, nothing is there. Now we have to configure our translation, port address translation. So this information is remain same. We have to define who is inside and who is outside. Then also we have to define our access list. We have to define which network I want to translate. No need to full, directly assign your access list, then come to your statement translation. Okay. But at this time, we have only one IP address. Only one, .1. Check the router, .1. So already we defined like which interfaces belongs to inside and which interfaces belongs to outside. Now we have to create our access list. Access list 10 permit. I want to define my network. Yeah. Then your network. So IP net. Again, your source is inside. You want to translate like source list. Just because we have a list, like we have an inside access list. So list your access list number. Okay. Now you want to translate your IP address based on the pool or interface. We have only one IP address, and that IP address we assign on to the interface. So we are going to translate our IP address based on the interface IP address. So here we have defined interface. Which interface? Interface name. Fast Ethernet 0x1. Then we have to type in the last overload. With the help of this, you are saying, okay, it's a port address translation. Port address translation. The translation.
All the PCs will be having connectivity.
Yeah, now all the pieces have connectivity. Just check. So IP net translation, nothing is there. Come to the laptop 1. Okay. We have disability. Laptop 2. We have laptop 3. We have. Come to the router and check the translation table. It's a translation. Your private IP address, your public IP address. You can say public IP address is .1.1.1.1. This is your interface IP address. But what about the port number? It's a difference. This is our simulation. That's why they are assigning this 1024 also. But in the real time, you will get the apart from the 1024 because these are the reserve port number. So except that reserve port number is going to assign it.
So you don't think that
100.
10. But interface assigned here 10.0.0.1.
Yeah.
The master packet route to run.
Your destination is this ISP. Okay, you are sending the request from the PC1 to the ISP. So what's your source IP address? 192.168.1.1. What is your destination? 100.0.0.10. This one. When this packet is reaching from your PC to the router. So in the router, we have one access list and then translation. With the help of that statement, your packet is going to translate. And also here you will get some random port number and the destination, like suppose something 21, just for the demo. Now when your packet will reach from the laptop 1 to the router. Now in the router, we have a translation net rule. So it's going to translate your IP address from 192.168.1.1 to 100.0.0.1. Like this. Now this packet is going to transfer from your router to the ISP. Now your ISP is going to send the reply. In the reply packet, what's your source IP address? Like destination IP address .1. When your packets reach here, is going to check your translation. We have one translation. In the translation, this is our private IP address. Like in the translation table, we have one thing. When your packet will reach to the router, so it's going to make one translation table 192.168.1.1, 100.0.0.1, and it's going to make some port number entry also. So when your packet is reaching to the router, router is going to check, do we have any translation entry? So yes, we have. So this is my public IP address and the private IP address. So we have to convert into this one based on the port number, because we are receiving here 1478. So after untranslation, your packet will reach to the laptop. Clear? Any doubt? You can create one more access list. Yeah, and you can apply. Yes, you will get it. Yes, yes, yes. Because you can see when you are creating access list, this is your access list format 192.168.1.0. You can create one more access list with the same number 10. You can get the visibility. Huh?
If I want to reach 200 network,
200 network. Where is your 200 network?
it's not defined.
Like here. So this is the ISP now. Like when you are receiving to the reach to the ISP know about this network.
It's my packet receiver because of recovery.
You can connect one more router here and configure as a DNS server or something other server and try it. Just I need a reachability from this end to this end, because it's my WAN area. It means I need a reachability.
In reality, ISPs knows about that.
Yeah, definitely ISP know about each and every WAN network.
Packet receiver करना है, तो then we need to add one device.
Just add one more route here and configure routing protocol in this area, not here, only this area. We need a connectivity from here to here. Then we have to translate our packet. Then do this one. There is only one line of command. Just we have to define our translation. This one, IPNet source. This. For that we have to create one access list. That's it. This is your port address translation. Huh? Maybe DSL. I hope you already know. Already we done.
Sir, hello.
Yeah, what happened?
Sir, in both cases, like our router is forwarding.
Just 1 minute, 1 minute, 1 minute. Yeah. What happened? Rakesh?
Router to ISP and ISP to router, source port and destination port will be same, right? Means our router is forwarding, translating one IP with different port number. That is my source port number, right?
Yes.
Source port and my destination is 21.
Actually, your port number is going to assign here only.
On router,
On
router only. Router will assign the port like 1478 to my IP, right?
Yes, to your
My local IP. And my destination port also it will be there, right? 21. Like
destination port like depend like what you are trying to use.
any
Like
port.
80 like you are using HTTP, so your destination port is 80. You are using HTTPS, then your destination port is 443.
When reply comes from ISP, then same thing, right?
Same thing, just your source will become a
Port.
destination and the destination will become a source.
But the port number will
Yes.
be same. So
Same.
source port and destination port.
Because we are translating our IP address based on the source port. So your source port is remain same. You are converting your IP address and your router is going to assign you this port number. So this port number is reaching here, and while replying also you will get the same port number.
Okay.
Okay. Yeah, do this task.
Yes.
So Venkat is that net, because like net denoting is your translation. When you are using the pet, in the pet, we are adding one more command here, like overload. IP net something, where is it? We are adding this line overload. With the help of the overload, that word, we are translating our net into the bed. Net is going to denote you as a translation. I want to translate my IP address. If you are not if you are not adding this line, this word, it means it's your pet. When you are adding this one word, it means it's your pet. Without this one, it's just a network address translation. But when you are using this word overload, it means you are converting your net into the pet. Net is just denoting like I want to translate my packet. Okay, guys, done? Done. Okay, so the next task is just DHCP. DHCP. Door. That we have to do. It's good now, like summer, so we need AC. 28. Really? Okay, so the next topic is DSCP, the last topic for today class. DSCP. So just tell me guys, why we are using the DSCP? Directly assign the IP address. Like what? For getting the IP address automatically, we are using the DSCP. For this kind of scenario, we need one DSCP server in our environment. Okay. So like suppose you have one friend. Okay. You need some movie from your friend. Some movies. Can be anything, Avatar, anything. You need some movie. And you don't know like whether he has that movie or not. So what's your first task? Asking. We are asking, do we have that movie or not? Then second, what? Then is going to send the reply. Yes, I have. Yes, I have. Then give me the movie. I want to watch that movie alone. Give me that movie. Give me that movie. Okay. And the fourth, he'll give you that movie. So how many packets we have? 4. I want to send the request like, do you have any movie that anything? So it's saying, yes, I have that movie. So I'll bring my pen drive and just give me that movie. So it's going to copy from this laptop to my pen drive and I can plug in my PC and I can watch it. So total, how many conversations we are doing? How many packets? Total 4. So in this scenario also, we have the same things. This is a client. This is your client. Okay. And this is your DHCP server. In the DHCP server, we have a pool. DHCP pool. Like whenever I'm receiving any IP address here, just start your CMD. IP config, you can see here, I got the IP address automatically. It means I have some network pool in my router. And I have one pool. From that pool, I'm receiving the IP addresses. So I have defined one of the pool, network pool. Now, I need IP address. So again, we have 4 packets like this ask, then it's going to check, do we have or not? So total 4 packets we have. Like this. So in the DSCP, we have one term, DORA. Okay, not that DORA in the cartoon one. Okay, this is a DORA means discover, offer, request, and the acknowledgement. Discover, offer, request, and the acknowledgement. Discover, it means you have one WhatsApp group, friends WhatsApp group, and you are sending like, I need that movie. You are sending that message, like you are broadcasting that message. That message will reach to the everyone. Then if someone have that movie, they are going to reply, yes, I have that movie. Okay. So in the offer, your friend sending the offer, yes, I have that movie. You want that one? Okay. In the request, the friend say, yes, I need that movie. I'll bring my pen drive to you. So he's sending the request, yes, I need that movie. Then your friend acknowledge, okay, take it. Okay. Got it? DORA. So first one is a discover. Then offer. Your friend is sending offer. Yes, take it. Offer. Then I'm sending request. Yes, please give me that IP address. Here we need IP address. And then acknowledgement. So your client it's sending the discover. It means he doesn't know about like where is my DSCP server and how many DSCP servers we have in our network. Like same like in your friend circle, you are sending the message to your group, not particular one user, not particular one friend. I'm sending that message into the group. If someone have that message, if someone have that movie, that user, that friend is going to reply to me. So same like I'm sending the discover message. I need some IP address. You're sending the request, you're sending the discover message. I need some IP address, and this one broadcast, and that packet will reach to the every connected devices. Now, suppose in your environment you have some devices, and one of the devices it's a DSCP server. So your DSCP server is sending, yes, I have one IP address. You want this IP address or not? It's sending the offer. First, discover packet will reach to the DSCP server. Now DSCP server is sending the offer letter to that particular user. Okay, I have one of the IP address. Do you want that IP address or not? So the client is sending the request. Yes, I need that IP address. Please assign me. So in the fourth one, your server say, okay, this IP address belongs to you. This is your DORA process. Okay. In the Cisco devices, all 4 packets will be broadcast in the Cisco. But when you are talking about the Windows, then your second and the third packet is a unicast, depending on your operating system. But we are learning about the Cisco, so all the packet is a broadcast. Now, Cisco packet tracer. I need only one device, 2 devices. One is my laptop, and the second one is my router. I want to convert my router as a DSCP server. That's it. Okay. You can convert your router as a DSCP, DNS server, HTTP server, FTP server. We have flexibilities. First, assign the IP address. Interface F0 by 0, IP address 192.168.1.10, 255, 255, 255.0. Then no shutdown. Now we have IP address. And just change the host name. DSCP server, DSCP. Okay. Now, this is my DSCP server. It means in the DSCP server, I have to create one pool, DSCP pool. So come to the router, it's very complicated. IP, DSCP, pool name, test, and in the pool, we have to define our network. Network 192.168.1.0, net mask 255.255.255.0. Done. This is our configuration. So IP DSCP pool, full name and the full, we have to define our network. That's it. One by one. One by one. In the network, like we defined. Now, come to the PC and select this DHCP. Just wait. You can see. We receive the IP address. Yeah, this is our DHCP now. We receive the IP address. But there is a one issue here. You can see the default gateway. We didn't receive any default gateway. Why? Because we didn't define that. You can see here, I have my default gateway. And this default gateway I receive automatically. It means I have to define my default gateway in my DHCP server. So assume like in this scenario, I have only 2 devices. So this router is working as a default gateway also. So I have to define default router. Default router, it means default gateway. And here I have to define my default gateway IP address 1.10. Okay. Now again come to the PC. Again send the DORA process. Now you can see we got the default gateway. Okay. Now again you can see like I don't have any DNS server. But when you are talking about the real time, so maybe sometime we are assigning our DNS server manually, but sometime we are receiving automatically. You can see here, I'm receiving my DNS also automatically. So in the DHCP server, we have to define our DNS entry also. Come to the router, DNS server. Was my DNS server 8.8.8.8. Come to the PC, again send the request. Now we have entries. 192.168.1.1 is my IP address. This is my subnet mask. This is my default gateway and the DNS. Okay. So with the help of the DHCP, you can get the IP address automatically. One more time. Simulation. Now this time we have to capture our packets. Laptop. Static. DHCP. 1, 2, 3. Okay, it's better to capture in the wires arc. For the capturing the packet now, your Cisco packet tracer is not good.
Different IP address.
Yeah, we can give the different network also. It depends on which interface you are connected. And one more thing, meanwhile, we can discuss about this port numbers and all. Any idea which port number they are using? DHCP? And they are using 2 different port numbers, 67 and the 68. You can see here, this one.
हाँ ठीक है चालेल हरकत नाही हाँ चालेल चालेल चालेल
Okay, you can see here, this is your packet of the DHCP. It's working on the layer 7. Okay, and it's using the UDP port number 68 and the 67. 68 from the client, 67 from the server. Okay, for the client, 68, for the server, 67, the port number. And your all packets are broadcast. Your all DHCP packets will be broadcast. Each and everything. Broadcast. Okay. The DHCP is working on the layer 7. It's using the UDP port number 68 and the 67. 68 for the client, 67 for the server. This is your DHCP. Now, just 1 minute. We have to discuss one more thing. two routers. Start your device. This is your client. And this is your client. So meanwhile, we can type our commands. So this is my DSCP server, DSCP. Enable MPT interface 0 by 0, then IP address 192.168.1.10.255.255.255.0. No shutdown. Exit IP DSCP full test. Then I have to define network 192.168.1.0. Then while subnet mask. Then default router 192.168.1.10. This, if we need them, and also if you want to define DNS server, so this is your command. This is your client. Okay, this one. No. That's it. Change the host name. Yes. Okay. Now capture the packet 0 by 0. Come to the client and send the DSCP request. Client. Enable config T interface 0 by 0. For no shutdown, then IP address. What is your IP address? DSCP. We have to receive the IP address from the DSCP because this is my client. You can see we received some message. And we got the IP address. Okay, 1.1. Stop the packet. It's visible. This is your discover, offer, request, and the acknowledgement DORA process. Okay. Now, in the offer, like what we are offering to our client, IP address. Which IP address? You can come to the DSCP offer, and you can check here. 192.168.1.1 is offering this IP address. Okay. This is your DORA process. And also you can verify which source port number they are using. In the discover from the client to the server, it means 68 to the 67. From the server to the client, 67 to the 68. Okay, this is your DOA process. And in the offer, we'll get the idea which IP address they are assigning, 1.1. Okay. And one more thing, I forgot to tell you from here. Like suppose in your environment, we have some DHCP server, DNS server, HTTPS server. Okay, just tell me it's a good thing. Like we need I take the IP address from the DHCP server for this DHCP DNS, or we have to assign them manually. According to you, what we have to do? DHCP. Like suppose you have one HTTP server here in your environment, you have one HTTP server. So do we have to assign the IP address manually, or we have to take the IP address from the DHCP server? Definitely we have to assign the manually because my server, if I'm receiving the IP address from the DHCP server, so I don't know which IP address is taking. And there is a one least time for the IP address 24 hours, means 1 day. Means after the 1 day, again it's going to change his IP address. This is my HTTP server. I need one IP address, static IP address. So we have to use static one. So suppose to the HTTP, I define my IP address .1 manually. But this DHCP server doesn't know about this static IP address. We assign .1 already. .1 is occupied for this server or not. The DHCP server doesn't know about this one. So what I'm going to do here, I'm going to exclude some address range. Like I want to tell my router, please don't assign any IP address from the .1 to .10 because this range belongs to the servers. Okay. So come to the route, your DHCP server, exit, IP DHCP, exclude address. Starting IP address 192.168.1.1, then higher IP address 192.168.1.10. Come to the PC, previously it was a 1.1, now again send the request. Now you can see it's receiving the IP address except the range. 1.11. Okay, this is your DHCP server. If you have two different networks, like I need one more IP address, here I'm going to create one more pool, IP DHCP pool test 2. And this I'm going to define my network 172.16.1.0, 255.255.255.0. Okay. Default router 172.168.1.10. Just tell me this IP address range we assign anywhere in our router? No. So it's not going to use this pool. Suppose I have one interface. I took one PC and this PC is connected with this interface. The F0 by 1. Exit. Interface F0 by 1, assign the IP address. IP address 172.16.1.10 to 255.255.255.0. Then no shutdown. Nice. Okay. Just 1 minute. Interface F0 by 0. IP address 192.168.1.10. 255.255.255.0. Now, interface F0 by 1, IP address 172.168.1.10, 255.255.255.0. Then no set. Now we have two information. So IP interface 2, 192 network and 172 network. Okay. On F0 by 0, which IP address assigned? 192, and on this port number 172. When this user is sending the DHCP request, this request will reach to the router and is going to receive that information on this port number F0 by 0. And on this port number, we have 192 network. It's going to check your DHCP pool. Do we have any pool regarding this network or not? 192. If we have, then it's going to assign the IP address from this range. We are receiving the DHCP request from this PC on this interface. On this interface, we have one IP address 172. Is going to check your DHCP. Do we have any information about this? Yes, we have. We created one more. So it's going to assign IP address from the test 2. can check here. One second. Okay. Okay, guys.
IP address खत्म हो गया उसके बाद TCP
So you can use class B. That's why we have a class A, class B, class C. If you have a lots of IP addresses, so you can use class B IP address. And then we have 65,000 IP addresses. I guess you don't have any this much PC in your environment. Okay, online guys, any doubt, any query? Yeah, Rakesh Venkatesh, any doubt, any query?
Yes, yes.
No,
yeah.
sir.
I have no doubt is there. Just want to confirm that this IP pool can be translated on internet through PAT or NAT.
So again, you have to like this is your ISP.
Right.
On this port number, you have to fire the translation, port address translation. So yes, definitely you will get the reachability, internet connectivity. Let's try.
Okay.
So suppose this is your ISP, okay, and
Right.
I'm using the which one? Port address translation, PAT, ISP1. Okay, connect the cable. Come on, man, connect it. It's my new router, and I have port number. Okay, first we have to turn off that router. So do one thing, just write, save this configuration. Power off. Okay, here we don't have port number. Okay. Power off, and now we have one power. Power on. Close. Yeah. Okay, done. Now, still booting. Now assign the IP address. On this side, I'm going to use 100 network. Okay. So come to the CLI, enable config T, interface. Which interface is it? F1 by 0. F1 by 0. And the IP address is 100.0.0.1.255.255.255.0. Okay. Just 1 minute, guys. Access list. I'm going to create 10. Permit 192.168.1.0, 0.0.255. Okay. Now again, I want to create one more access list. Permit 172.16.1.0. Okay, we have two access lists. Interface F0 by 0. IPNet inside interface F0 by 1. IPNet inside interface F1 by 0. IPNet outside. Okay, done. Now our IPNet inside source list access list 10. Then interface, which interface? FA1 by 0. Fast Ethernet 1 by 0, then overload. Done. So configure this router. Enable config T. Interface F0 by 0. Then IP address 100.0.0.10 255.255.255.0. No such thing. Now, we can check, do we have IP address here? Yes, 1.10. Just 1 minute, I have to check one thing. Here I define 1.10, okay, and here is 10. Now check the reachability. Ping 100.0.0.10. You can see we have reachability. Come to the router and check the translation table. So IPNet translation, is there an entry? Okay. Now come to the here and check, do we have reachability? ping 100.0.0.10. So yes, we have reachability. 172 is going to translate on the 100.0.0.1, and 192 also is going to translate here.
Okay.
Okay. Do this one in your laptop. We will discuss. I will check your topology tomorrow.
Okay,
Yes,
sir.
sir.
Thank you.
Okay, then see you tomorrow. Now with this, with that part only, with that part also, just create two pool, connect two networks, and do some translation. Okay. Okay, then see you tomorrow.